Landing on anything other than your heel is inefficient. I know that sounds crazy and inflammatory, but hear me out. This is Heel Strike Dissertation, medium length. I posted recently a full hour for those of you that want even more details, even more of the why. This is going to be more of a medium length, and it's going to be the same concept, the same message, but a slightly different perspective. I'm going to present it a little bit differently. People learn differently, and hopefully this will help to reach a lot of you. And again, if you're happy and healthy, I'm happy. I'm trying to offer information to help you make an informed decision of how you want to land. But I want to clarify a lot of the misconceptions out there because there's a lot of them. So again, my goal for this is to give you the information you need to make the decision yourself. But we're going to get into this. Landing on anything other than your heel, midfoot or forefoot, is inefficient. So we're going to reverse engineer. A lot of times it's helpful to begin with the end in mind, work backwards, put it all together. So we're going to be starting with foot strike. So to be clear, when differentiates running versus walking is this period of flight time. We're in the air. Then when we land, we make contact with the ground, that's what we're talking about here, foot strike. And so we're going to ask, how did we get here? Go backwards in the various phases, apply concepts of gliding, gold standard, movement physics to be able to explain which one is the most efficient and why. The cost of movement. There's a cost to everything. We're going to talk about the cost to not only when we land, when we're absorbing force, every action equal and opposite reaction. Our body has to absorb that so we don't collapse. But then we're also going to go backwards to the propulsion piece, how we actually translate and move forward in addition to the landing. So we're looking at propulsion and momentum. Here's the theoretical framework that I like to use, the marathon mortgage. This is going to we're going to apply this concept to everything we're doing to hopefully be able to understand and categorize this a little bit better. But here it is. We've got a mortgage, we have a house payment. We have a marathon, a distance. We're going to dissect each one payment each month, we'll say, towards the house, and one payment with each step, dissecting running into one individual step, translating forward. So we have the payment. When it comes to the house, we're spending money. When it comes to running, we're expending energy via the muscles. The muscles are our movers. And then with each of those payments, we're going to ask ourselves, with the mortgage, is that payment what is going towards the principal of paying off the house versus the interest, not going towards payment of the house, versus running? Running, the goal, the principle, is moving forward, not up in the air. Anything that we're doing, that we're exerting, that's not helping going towards the goal, the principle of moving forward, is paying on the interest. So we're going to differentiate that payment, what's going towards the principle of moving forward versus the interest of going up. And unfortunately, we can't stop there. We've got to pay taxes. The ground is where we're going to be spending and be taxed on that movement. Every action equal and opposite reaction. No matter what, the ground, when we land, when the foot's out in front, it slows us down. That's paying the taxes via the ground, Uncle Sam. So therefore, our goal is, how can we minimize as much as possible being taxed, minimize braking and slowing down? And this gives us our running economy, our efficiency of forward movement. First, let's define what is the gold standard. What is the gold standard of running? Gliding. What is gliding, you ask? Gliding is two parts, two components of gliding. The first is leaning. The second is leaving the ground. So we're leaning forward in such a way that's minimizing braking, and we're leaving the ground moving purely horizontal with the goal of maximizing forward translation, distance with each step, and minimizing braking. Said another way, maximizing momentum. So the gold standard gliding is translating moving forward, slowing down the least. Let's zoom in a little bit closer on the leaning and the leaving. So we have here figure one. I'm leaning forward. If you've been following me for a while, my way to remember this is the ankle, leaning forward, hinging at the ankle. My shoulders are still stacked over my hips, over my ankles, but my pressure, my weight is shifting from the heel arches to more the forefoot, the front of the foot. And the folding, the hinging where it's occurring is at the ankle. Figure two is the leaving the ground, the push with the tush. Leaving the ground, moving purely horizontal, staying below my height with standing. I'm 6 feet tall. I should be able to run in a room that has a ceiling height that's 6 feet tall, that I'm not going to go up and bonk my head because I'm leaning, because I'm leaving moving horizontal. So these are the two components of gliding, leaning and leaving. We're going to start with leaving the ground. What does it look like? Here it is. Ideally, the moment we go into flight phase, the moment that our foot comes off the ground, we're in the air, we move horizontal. We move forward and then down versus up and then down. So let's get some simple shapes on this. I like using simple shapes to try to think of the body as one individual unit to help to get rid of some of the clutter, to help to conceptualize these concepts a little bit more. So back to figure one with the leaning, everything stacked, leaning forward, shifting the weight forward, hinging at the ankles. And then figure two is leaving the ground, moving horizontal. Horizontal and forward, and not going up above my standing height. So now that we've got the gold standard, let's apply that concept, two components, reverse engineer foot strike to make sense of this. So here's the model we're going to use. These are the various phases, 4 phases. We're going to begin with the end in mind, with the landing to the ground. Going back a step, flight phase, when we're in the air, both feet off the ground. The step before that is leaving the ground, that individual moment. Some of these are specific moments and some of these are phases, where if you're thinking about this being a video and framed, one individual picture versus several frames as it's more of a process. And then going back one step is the balance position. I like this position, it's known as mid stance, because it's easy to kind of theorize what's going on. What's the posture? Where is my body weight, my center of mass in relationship to my foot when I'm in this position where I'm at my lowest height? Arms are parallel, thighs are parallel. This will give us a component, an idea of our momentum, of where is our center of mass, which we'll get into, which is going to dictate gliding versus braking. So let's get some simple shapes on this. These are the 4 phases. Landing the ground, we see the rectangle, the body, the foot's out in front. Then we have the flight phase, no contact with the ground. Then we have the leaving the ground. This is the propulsion phase, how we move forward. We see the foot's behind us, center mass forward. And then going back, the balance, when our body is over our foot, when we're at our lowest point. So let's do process of elimination. Let's take, first and foremost, biggest bang for our buck. Let's knock out forefoot and midfoot and take that off the table as being less efficient or inefficient. So why is this? How can I say this? Let's go back to our mortgage marathon theoretical framework. When it comes to the payment, the propulsion, the leaving the ground, we talked about interest and principal. Interest is going up, principal is going forward. Think about how, another way to say this up is jumping. If I'm jumping, if I'm going up, how do I do that? Well, I push downwards through the ground. I want to use the calves to push down to go up, and I want to push through the midfoot. So to land on the midfoot and the forefoot, to even get to this position, we're going to be jumping. And hopefully that's an aha moment. We're trying to take the jump out. We're trying to leave the ground, move horizontal and down, not leave the ground and go higher than my standing height. So let's get another visual on this and see the reverse engineering phases. So we're going from that flight phase, going backwards, both feet are off the ground, just in the air, airborne, to then when we're leaving, how we move forward, how we translate our entire body as one unit forward is pushing the ground back to move forward. So here's what it looks like to be paying on the interest, going up in vertical. At the highest point, back foot's off the ground, versus with the gliding, paying on the principle. If we look at the highest point of the runner's head, that back toe is still on the ground. And what this tells us is then when we go airborne, when we're in that flight phase, we're moving forward and not continuing to ascend and having both feet off the ground when we're at the highest point and continuing to go higher. So let's go back to the fundamentals of physics. I want to think of this in terms of arrows, thinking visually about arrows when it comes to movement and direction. And hopefully this makes it even more clear. We're going to use our boy Newton. Newton's third law. For every action, there is an equal and opposite reaction. If I punch the wall with 100 pounds of force, it's punching me right back with 100 pounds of force. So if we're our goal, destination, all things movement, if I'm trying to move forward, move my body forward, A to point B, action to the ground, push the ground back, the result is moving forward. We call this walking. What if I'm trying to go forward faster, further? Well, this is where there comes a point with walking and running where it's more efficient to leave the ground and to move further horizontal. If we were to look at your step distance in the sand, the slower you go walking, as we continue to go faster, we should see an increase in the distance between steps as we continue to go at a faster pace. So what changes? What doesn't change? We still have the action of pushing the ground backwards. The result is we're moving forward. We call this running. Walking and running, both in the same direction, the same goal. So the mechanics, push back to move forward, should still be the same. Talked before in the last longer one about the 3 F's. What does change is we push the ground with more force, further back, and a higher frequency. But this is what happens without training, without actually working on your mechanics. This is what's going to happen. We're going to pay on the interest. We're blending, pushing backwards and down. We're pushing the ground down and back as opposed to just purely pushing the ground backwards. So the resultant force of pushing down and back is the body translates up and forward. We call that bounding. If we were trying to jump and move vertical, and this is where running uphill is a different story. We're talking about running on a flat surface. If I was trying to go vertical, then yes, I want to push down to move up. But the blending of jumping and running is what we get with bounding, which is paying on the interest, which is midfoot and forefoot. So I mentioned before, the definition of bounding is leaving the ground, moving vertical above your standing height. Let's get a visual on that of bounding and gliding side to side and also overlapped. And you'll notice that horizontal line when I stay under it versus going over it. Again, bounding, blending, running, and jumping. So this is where the push with the tush comes in. This is where I talk about use your glutes, your glute max, your tush at the hip joint to push the ground backwards to move forward. The analogy I like to use is the paddle in the canoe. How we move forward in the water in a canoe is with the paddle, like your leg. You push the ground back, you push the water back, we move forward. That's our engine. That's our propulsion piece. So this is where the push with the tush. Use the glutes to push the ground back to move forward. Can we learn to not use the quads and the calves to push down and jump and go up and forward? Let's start the actual process of reverse engineering so we can see a visual of forefoot, midfoot. If we go backwards and see where does this blending of jumping and running or bounding take place? Let's start with the forefoot. So we've got the landing on the ground. You can see there, I'm on my forefoot. Backwards a step, flight phase. Both feet are off the ground, how high I am. And then we go down to leaving the ground right before I'm airborne. It's at this point, if we were to look, highest point, back foot off the ground, I'm leaving the ground and moving vertical above standing height. This is bounding, not as efficient. Back to our payment, we're paying more towards the bank, more towards the interest, less on the principal. We're leaving the ground and moving up and forward. I'm sorry I'm going to say that 1,000 times, but hopefully that sets in. Running is about moving forward. Now what about the midfoot? There I'm landing with my midfoot in the landing phase. Go backwards a step, flight phase in the air. Backwards a step right before leaving the ground. Same story with this. Bounding, moving higher than my height in standing. Let's clarify even more of the why to make even more sense of this. Leaving the ground influences the landing. What do I mean by that? So if we look at the top left, the pressure, where I'm pushing straight down through the ground with the ball of the foot using the calf muscles, going up, my foot, the position of my foot, if you look at that image of just my lower body, back foot's off the ground, what position is my front foot already in? That's the leg that was just responsible for the propulsion, pushing down. So my foot, my ankle is already in that position. Therefore, when it comes time to land, I'm kind of already in the position that I left the ground in. Versus the gliding, it's not pushing straight down, it's using the whole foot, pushing the ground back, using the glute muscles, and the result is landing more towards the heel as opposed to the forefoot and midfoot. Here's the other aha moment. When we're gliding, when we're having this flight phase where we're in the air, where it's less of this up and going higher, more of just translating forward, we're staying closer to the ground, there's not a lot of time for any extra movement in the front. It happens so fast. So as soon as we extend and push the ground backwards, there's really only time to land with your heel in the front. There's not time to land on the forefoot, land on the midfoot, as we're staying closer to the ground and translating horizontal. So thus far, keeping track, we've used the component of gliding, of leaving the ground, forward propulsion, to take off forefoot and midfoot off of the list. Now we've got the controversial, we've got the heel. So we're left with the heel. Let's use the other part of gliding, the leaning, the momentum, to help explain this. So again, we had leaning and leaving. We just did the leaving the ground. Let's break down and use the component of leaning our body weight forward, the ankle hinging at the ankle, to explain and differentiate the heel. So what should this look like? So here I am at that mid-stance position, the balanced position. Notice that my weight, where is my body weight, my pressure? And we'll go into some visuals of this more later. I'm forward, slightly forward. So the gold standard, this is what it should look like. So here we are. We've got 3 different scenarios. What you'll notice, all 3 of these landing on the heel. But what's different about these? Take a look. What's different about all 3 of these scenarios? Does it help if we just look at the upper body? Where's my torso? Where's my body weight? So we can start to see some differences here. Same landing, but what's different? Let's use some foundational knowledge of physics to help clarify and differentiate these 3 scenarios. So this is Momentum 101, the braking effect. So look at the right here, we've got 3 different components. Base of support, center of mass, and then line of gravity. If you look down at the image of me, you've got your base of support. Let's begin with the ground, the foundation. This is like our platform. The points of contact to the ground from my body, that's the base of support, contacting the ground. Next we have the center of mass. This is where the average, where most of the weight is centered and averaged in an object or a person. And for humans, it's just right in front of the sacrum, S2, kind of near your belly button. And here, the line of gravity. Gravity is always pulling down towards the earth. The line of gravity is what differentiates the relationship between the two. Ideally, when the center of mass is directly over the base, when my weight is over my platform, when it's even, we're balanced. But when it comes to running and actually moving forward, we have the foot that goes out in front. So therefore, there's going to be a base of support in front of our center of mass. This is where we get braking. This is where we get slowing down. So we see the point of contact to the ground because we're airborne. Number one, the foot, that's the base support. Center of mass is still back, and the line of gravity. So the distance between the center of mass, that green circle, and the base support, this is where braking or slowing occurs. And here's the thing, braking will occur until the point where they're directly stacked over each other. Until the center of mass is over the foot, the base support, as long as the base or the foot's out in front, until that point comes where they're both vertically stacked and aligned, there's going to be braking that occurs. So let's take a look. The red is when signifies braking until this point here with the green where things are stacked. So therefore, the greater the distance between the center of mass and the base support, the greater the distance between the foot out in front and the body, the center of mass, the greater the braking force is. So therefore, our goal should be to approximate these. How can we make these as close as possible together? We've got two different options. We can either, one, bring the leg back closer to the center of mass, closer to the body to approximate. Or number two, we can bring the center of mass, the body, forward closer to the leg. Just saying that out loud. Do we want to bring something back versus bring something forward? With the goal of running, moving forward. We're trying to move forward. So let's get even more of a breakdown of that. First one, you see, bringing the foot back, number one, bringing the base of support backwards towards the center of mass, versus in the second piece, how are we doing that? How are we bringing the center of mass forward closer to the base? That's where the leaning comes in. That's where the leaning forward, shifting the body weight forward, brings the two closer together, the center of mass and the base support. So if we look at option one, bringing the leg backwards, versus option two, bringing the body forward. Number one, I'm vertical. Number two, leaning forward. What's the other big difference between these two? Both are minimizing braking, but what are we sacrificing? We're sacrificing distance. If we're bringing the foot back, the step length, the distance traveled, becomes shorter. So with each individual step, each payment, I'm not moving as far. I'm going to be leaving some money on the table. So therefore, ideally we approximate by leaning the body forward as opposed to bringing the foot back. And this is where it's crazy when it adds up. Just like a 30-year mortgage, 1% can make a huge difference in the end. Even let's say, theoretically, if we were shortening the stride by only just 1 inch, if the stride went from 4 feet 1 inches to 4 feet 2 inches, even that 1 inch less each step over the course of a half marathon, 13.1 miles, we would create a deficit of 0.36 miles or 582 meters. So we're going to be slower. We're going to have to take more steps to get destination point A to point B, more payments towards the house, towards the principal. So now that we know we want, of those two options, we want to lean forward versus bring the foot back. But where should we lean from? This is really important. And when we say from leaning, it's the joint. We have two options. We can either lean at the hips, shift our weight, lean the body forward, hinging at the hips, shoulders go out in front, hips, center of mass stays back, versus the ankles. So if you look up top, here's hopefully another aha moment. With the hippie versus the ankle, we can see that I'm leaning forward. We can see that my hips are staying back, my torso is forward. Watch what happens. I have a stick out in front, which is wide in my base support. What happens when I lift that stick up? Nothing. I don't go anywhere. Versus the ankle, when I'm leaning forward, having my pressure go to the ball of my foot, bring my hips and shoulders forward together, hinging at the ankles. What happens when I lift that stick? I fall forward. That's forward momentum, moving forward. So let's go back to these three scenarios, or scenarios, if you will. 1, 2, and 3. I want to share with you a little secret. This is a way to kind of conceptualize this easier, I hope. Think of this like a clock. If the torso of the body is like an hour hand, of these three, now we can clarify this and categorize this a little bit easier. We've got 12 o'clock posture, not leaning at all, vertical. We have 1 o'clock posture, and we have 12:30. What's the differences between these? Now let's think of a kind of a top-down, going back to the physics. Where's the center of mass? Where is the foot, the base of support? In the first one, where I'm not leaning forward at all, I'm vertical, keeping my weight back. Look at the amount of distance between my center of mass and the foot. Moving a little bit closer forward with the hippie, that's how we get that 1 o'clock posture. Shoulders forward, but hips are staying back. So yes, it's a little bit closer between center of mass and base of support, but still we're paying more taxes. Versus the 12:30 posture. Weights forward, heel is closest to the body. We're having a shorter distance between the center of mass and the base of support. So as far as taxes, from the left, scenario 1, we're paying the highest taxes. Versus scenario 3, minimal taxes. Again, remember, we have to pay taxes. So let's go back to the reverse engineering phases. Let's start with the 12 o'clock posture. So we look, there's the landing, going back the flight phase in the air, going back to leaving the ground, and now let's go back to the balance phase. Where's my weight here? If I were to just bring this to life, imagine like there wasn't the component of the momentum of running, what would happen? I kind of fall back because my weight's back within the base of support. So therefore, this is braking. So yes, landing on your heel, if your weight is back, not efficient. What about the 1 o'clock posture? Going backwards from landing to flight to leaving the ground to the balance phase. My weight is slightly forward more, but my hips are staying back. So therefore, if I'm landing on the heel in the 1 o'clock posture, not efficient, braking. So what are we left with? The ankle, landing on the ground, heel, flight in the air, leaving the ground, back to the balance. At this point, my center of mass, when I'm at the lowest point of my body, arms and thighs both parallel and even, my weight is slightly forward. Because I'm hinging my body weight, leaning forward, hinging at the ankles, my weight, my center of mass is more biased towards the ball of the foot, therefore approximating the landing and my body. So here's what it looks like with the Marathon Mortgage. Lower taxes, 12:30 posture. Higher taxes, 12 o'clock posture, 1 o'clock posture. So this is where people will say landing on your heel is not efficient. It can be true, but hopefully we're having the aha moment. It's not about the foot. It's more about the center of mass. Where is the center of mass in relationship to the foot? Heel striking is the most efficient strategy when gliding, but we have to make sure we're gliding. Here's the coolest thing. If you lean your body weight forward appropriately, if you leave the ground appropriately, pushing the ground back, moving forward, what naturally happens, and you don't have to think about it, is you'll land on your heel, close to your body. When you've got the lean and the propulsion piece right, don't think about the landing. Don't worry about the landing. It's going to happen. You focusing on the lean, focusing on the pushing the ground back, the landing will take care of itself. And what will naturally happen is you'll land on your heel, which is okay. So let's one more time put this together of the gliding and a top-down view of the physics. So ideally, here it is. We're now not reverse engineering. Let's start when we're at the lowest point, this mid-stance position. My body weight, if you look at the green center of mass, is biased forward more. Then we see when we push the ground back, extending the hip to move forward, we're maximizing horizontal distance between each step. And now with the landing, because my weight is forward and landing with my heel that's naturally going to happen, they're closer together. So therefore I can maximize momentum, thus minimizing braking, and I can maximize horizontal translation between each step. Here's the action piece. This is what you can take away from this. This is where the rubber meets the road. Here's the recipe. Here's what you do. Lean forward, hinging at the ankles. What does this do? This approximates your center of mass and your base support, which will minimize braking. Push the ground backwards. Pushing the ground backwards is going to lengthen your stride, cover more ground. We're not braking because we're leaning. We're minimizing braking. We're maximizing gliding, which will maximize horizontal distance. And the result is gliding. All you have to do, all you have to think about. Master this so you can subconsciously not have to think about it. And once you lean forward and push back, there's no going up. So again, the decision is yours. However you choose to land, that's totally up to you. But the most efficient way to pay the most on the principal with the least amount on the interest, paying the least amount of taxes, is gliding, landing on your heel. Remember, I'm teaching, not preaching. The choice is yours. But I hope you'll make the decision to run smarter, safer, and faster. Questions, comments, concerns, please let me know down below. In Tush we trust.